Do you know this book? What about this one? Or 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 this one? All of them are mathematics books. And when you open them and study them for a while, you will realize that reading mathematics is not like reading any other novel. To get started, many books have this special word repeated often. See? Theorem, 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 theorem. As a first, vague approach, we'll agree that theorems are true mathematical statements, and that they are the atoms of mathematical knowledge, that is, its minimum constituents. Given this, one of the commonest problems for math students is understanding what theorems say. After all, if you do understand them, you will know mathematics. To do this, you'll need to comprehend accurately each word and each symbol in the theorem. Math books authors know this, and that's why they write definitions before the theorems. They also know that at the beginning, abstract definitions are hard to grasp. This is why some authors also add examples and explanations before or after each new definition or theorem. It is commonly the case that, when studying abstract mathematical concepts, people ask, "And how in the crap's name would this thing be useful to me?" That's why it is not rare to find in math books some paragraphs dedicated to the explanation of a problem that also give an idea of how what will be learned next will allow the reader to solve those very same problems. That is, they are motivation paragraphs. Usually, these problems have a historical precedent, a story of how a brave mathematician solved them. This justifies the addition of bibliographical notes or the explanation of the historical context in which the problem arose. This before or after a definition, theorem, or chapter. Once we have understood the context of the theorem and the concepts involved in it, we just need to verify that, in effect, the theorem is true. To do this, mathematicians write proofs, that is, sequences of logical deductions that allow every dedicated reader to verify the truthfulness of the theorem. Finally, to make sure that we have actually understood the content, we should test our knowledge by doing exercises where we apply what we have just learned. After all, one does not simply learn mathematics by reading, but by doing. Hence, in many math books, you will find at the end of each chapter or section a series of problems for you to solve and become an expert on the subject. There you have it, a map to mathematical texts. In the following videos, we'll look more closely to them and mathematics themselves. Subscribe for more.